today. Histograms, get your histograms. A lot of people usually like this unit because it's math-wise, it's not so extreme. It it's pretty good there. So let's do a little check-in. Are we back, friends? Friends and neighbors. Aiden, Junior's here. Good. Henry.
I'm here.
Awesome. Taylor. Corey, Isabel, Sarah. Corey's gone. Okay, I gotcha. Declan, Lily, Junior said they're here. Cool. There. I meant he. Oh, crazy. Crazy teacher. All right. So we're going to get started. We're going to learn about data today. Yay! So there's my two numbers on there. The first one is a really good number to text me at because it goes right into my email. The other one is in case you need to text me images. So for whatever reason, if it ever comes up where you want to text me some images, go ahead and click on that text that second number. Oh yeah, go right ahead. Please do. Both numbers will get a hold of me. The second one is really just for images. Oh, I think my cat is ticklish in the tummy. So I was petting his tummy and he was twitching. He was twitching. Yeah, he's so cute. He won't let me pet him. Come here. I know you want snuggles. Oh, this is what I'm looking at right now. My little kitten. He's 7 months. He's going to be a big boy. I love it. My other kitty just got spayed. I'm kind of worried about her because she's gaining weight pretty quickly. So I might have to take her back to the vet. Just want to make sure there's no issues from the spay. All right. So this is what is due this week. We're going to talk about best fit. That just deals with finding the mean, median, mode, and having outliers, and talking about how that affects things. And then we're going to talk about histograms. And the next one is a measurement application quiz. We'll look at that together. It's just using what we've done in more like word problems stuff, but we'll look at that. Which part? The best fit? All of it? Oh, gotcha. Well, we'll talk about what it means today. I know, I actually looked at it and I was like, wait, what's best fit? And then I looked into it and I'm like, oh, okay. It's not too bad. A lot of this data stuff seems really confusing, but I don't know. It's just kind of like finding the calculation and then figuring out what it means. So, you got this. You sure do. Okay, so first thing we're going to talk about is best fit. Now, this is kind of like a frequency graph, okay? And remember, what I would do if I were you guys, I would take notes on this stuff, especially if you're a little unsure, all of that stuff. If you don't want to take notes now, you can always go back, take notes later, you know, how it works, all that good stuff. So, okay, first thing I would do with a frequency graph, this shows, like, for example, if it's like, let's see, I would think of ages in a daycare, okay? So let's imagine, because I like to put meaning to things. This graph talks about ages in a daycare center, okay? And I'm just thinking of, so it could be anything else. It really could. And this shows the frequency of how many times those ages show up. So if you look at this graph, how many kids look like they would be 2 years old? How many kids? 4, right. There are 4 2-year-olds. And what I like to do, I like to list the data because it just helps me with calculating it. So I'll actually type it out at the top. What about 3? How many kids are 3?
0. Wait.
Well, they're not on there.
Oh, I see them. Never mind, 2.
2, yeah, 2 of them, because it's not on there, you're right. But the graph looks like it's going by even numbers. You're counting by 2s. So I think they just did that so the numbers wouldn't be too crowded. How many kids are 4? 3 2s? I think there's 4, just because there's 4 dots above the 2. And there are 4 dots above. Oh, that's okay. Please ask, please, because if you have a question that pops in your brain, chances are it popped in someone else's brain. So there are 4 4s. What about 5-year-olds? How many 5-year-olds? 1 5-year-old. What about 6-year-olds? 2 6-year-olds.
There are 2.
Yep, you got it. What about 7-year-olds? 1, good. 8-year-olds? 2 8-year-olds, good. And what is the very last age of someone in this daycare center? 22. Yeah, you guys might be like, wait, what? 22? How could that fit for daycare? Actually, it's kind of interesting. At the daycare at my husband's work, there is an older person who's in there. I don't know how old they are exactly, but they're definitely older teen years. And they're special needs. So they go into the daycare while their parents work out. So, you never know, right?
I thought it was just like a middle-aged man sitting in like the playpen with a binky in his mouth. That's what I imagined first.
I know. I honestly thought of that when I came up with the example. I did, but then I was like, well, hold on a minute. It could either be the daycare worker, or if this is relating to people in there, this could be a special circumstance where someone is, you know, special needs, because that happens. So I wish that would be my child, but he absolutely refuses to go into daycare. So I have to work out when he's at school. That's okay. So, okay, so this is our data. We have, how many pieces of data do we have? I typed it at the top, or you can count the dots. It might be easier to count the dots, actually. Oh, yay, you're gonna snuggle me. Yay, guys, I have a snuggle buddy. Yay, that's so nice. Thank you. He's so nice, yeah. 17 pieces, is that what you guys got? That's what I got. Oh, guys, best math partner ever. Oh, good. Good. Oh, he's such a good boy. I knew he'd like it better. I tell you. Okay, 17 pieces of data. So now what we have to do is we have to talk about the mean, the median, the mode, and the best fit. And best fit refers to which data piece, which measure of central tendency, because remember, the mean, median, mode, remember they're called measures of central tendency. Okay, so they talk about what most of our data is doing. That's what it's talking about. So let's find those. Do you guys remember how to find the mean? How do you do that?
You add them all together, then divide them by how many like assets there are.
Ooh, good word. Yeah, you're so right. We're going to add them all together and then divide by how many there are. And we already counted. Junior and then Lily said that we have 17 in our data set. Oh, you are such a baby. Sorry, I cannot help but baby talk this cat. It's ridiculous. He's my little buddy. Even though he catches my microphone cord and eats it. Stop it. Cut it out. There we go. No! So what do you guys got? Everybody should be trying to calculate the mean right now. And remember, you can use a really awesome calculator called Desmos. And I just typed the link in chat. Shows you exactly what you're calculating. Stop it. It's okay. Yeah. What do you guys think? It's probably taken a little bit. There's a lot of pieces of data there. I gotcha. So we're adding it all together and then dividing by 17. I will definitely give you time to do that. And remember, if you feel kind of weird about typing in what you got in chat, remember you can write it or type it on the screen, and I cannot tell who is writing what. So if you feel kind of weird and you just want to see if your answer is close or whatever, just type it on the screen. No big deal, or write it. And ideally, we're wanting an average that's kind of close to our data set, but it might be a little off. And we'll talk about why that is.
I know what the median is. I guess I'll just
Sorry, Junior, that happens. It does happen. It's so annoying to calculate this stuff sometimes. It really is.
It's a bunch of numbers, and I just keep accidentally getting one number down or one number up and accidentally retyping something or something
yeah.
like that.
Yeah. Have you guys tried using Desmos yet?
I'm using it right now.
Okay.
It's what I use all the time.
Yeah, and you can even download a Desmos app for your phone.
1, 2, 3, 4.
Pretty cool. In fact, I should be on there. My snuggle buddy couldn't help attacking the microphone, so he left.
4. 1, 2.
Yeah, I'm adding on Desmos right now.
4 4s. 1, 2, 3, 4. Plus 1, 5, 2, 6, 1, 7, 2, 1, 5, 2, 6, 1, 7, 2, 8, and then we're 22. Except, I mean, isn't that a or are we gonna get to that in the future? It's a 22. I forgot what it's called.
Oh, it's a good word.
But it doesn't belong. It's too big and it messes up the mean.
Well, you're right, and we're going to talk about that. That is definitely a word that we're going to mention today, but we still want to include it right now in our mean.
Okay. And 92 divided by, oh goodness. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
I didn't get 12.
12,
But it
13.
seems like it would be 12. Why does I don't like the answer I got. It doesn't seem very.
Oh, I got 5.4.
5.4. I got 5.8.
I don't know. I divided
No.
it by 17.
Yeah, that's what I did. Wait, let me.
How do we have?
I think
Oh,
I
I know
got.
what you did. It did order of operations on you. You must not have clicked.
Oh, you're right. Okay, hold on. The bottom numbers. Well, what we're doing is good question. You remember
So
how we
I
talked about the different ages? So it was 2 and 2. So there were 4 2s, 2 3s. We're adding all of those numbers. So it's actually the numbers at the top that we're adding and finding the yeah, and that's why we're doing this because it's super confusing. A lot of people do the numbers at the bottom. Seriously. Yeah, no, I got you. We're doing all those numbers at the top. So sometimes you might even do 4 times 2 because there are 4 2s. And then add it to. See, that confuses me more though. How do I do that? Okay. I am just good. You got 5.4. Okay. Yeah, I don't feel like I did it right. I believe you guys. Let's see. So I'm going to go to Desmos. So we have. Okay, 4 2s. And then 2 3s. Oh, not 33. And then 4 4s. 1 5. 2 6s. A 7. 2 8s. Oh, yep, I did do it wrong. See, that's why we do this all together. Look at that, 5.4. That's totally what I got. Good stuff, guys. See, do you see
I
how
was right.
easy it is to do it wrong? It really is. I used the Desmos calculator app and it was kind of hard to type all that in. I recommend using the website, honestly. But we get 5.4. Good. Oops, it's in yellow, but that's okay. So 5.4, if we think about the data, 5.4 shows up about here-ish, right? So we would say kids in this daycare are about 5. I don't know, seems pretty appropriate to me. However, look at how many people. So that would be there's 5 pieces of data bigger, actually 6 pieces of data bigger than our average. And there's 8, 10. Ooh, there's 10 pieces of data less than our average. So I don't know. Seems a little not accurate, right? Because it doesn't talk about how many kids are 2, 3, 4. And that's a big deal for a daycare. Because kids who are 5, let's just think of it from a real standpoint, kids who are 5 can use the potty, right? If there are 10 kids who need help going to the bathroom and all that stuff, they might need to get some extra staff members in there. So that average might not be a very good way to talk about this data set. And it kind of fits in with what Aiden was saying earlier. That 22 affects our average. Okay, what do you think is going to happen if we take our average and we don't include the 22? What do you guys think? Do you think our average is going to go up or go down? Down? Yeah, let's see. Let's check it. Let's check it. I don't know. I agree with you there, my friend. Okay, so we're going to go up here. We'll clear this one. Oh, no. How do I undo? There we go. So we'll get rid of the 22. So we get 70. And now we got to divide that 70 by what number? Do we still divide by 17? By 16 now, yeah. Oh, look at that. It's 4.4-ish. So now it's like saying that our data is around 4.4. So in the fours. And that's a little bit better. It really is, because there's a lot of kids who are 4. So that might help bring in the proper staff members and stuff. So that's what it means by best fit. So now if we have to leave the 22 in there, let's keep going with it. What would the median be? What's the middle piece of data? The middle number. And we have 17 pieces of data, so we'll have one number in the middle. Yep, I see someone kind of crossing it off. That's a really good way to find the middle. That's good. And I appreciate how you're just crossing it off so other people can still read it. That's good. Very good work. See, guys, I love this. I love it when I'm talking and you guys are participating by doing stuff on there. It's so cool. I'm a happy teacher. Yay. Oh, look at that. So our median would be 4. Do you guys agree? 4. Do you guys agree with a median or a middle number of 4? Oh, well, that's a good reason. Yeah. What about a mode? What's my number that appears most often? And I might have 2, and that's okay. 2 and 4, yeah. So definitely, so when it says best fit, they're asking which measure of central tendency is a better fit of the data. And what would we say? Would we say the mean, the median, or the mode? Or 2 of them? What do you guys think? What is a better way? Like if I was talking to the director of this daycare and I said, well, on average, the kids in my classroom are about this. I probably shouldn't say on average, right? Because we don't want to make them think that is the right average. But what would I say? Would I say according to the mean, the kids in the classroom are about 5, maybe a little older? Would I say about 4? What do you guys think? What's a better way to say it? Remember, we said, yeah, I know this is a tricky part. This is the tricky part about data. If I said the kids in my classroom are about 5, okay, if I said that, we would want to ask ourselves this question. If I use the mean, if I said the mean was the best fit of the data, we might want to say how many kids are older than 5. How many? How many kids are older than 5? 6. There are 6. You're right. Good job, both of you. Good.
If you classify being 22 as still being a kid.
Right. Good point. Depends on the need, right? That might be a different question altogether. So what do you remember? Does anybody remember the word for 22? Like what that would be? Starts with an O. Ends with the letter. It is an odd. Well, it's not odd. It's an odd number out. You're totally right. And sometimes people word it like that. You're right. But the mathy term we would say is outlier. Yeah, I might do what Junior's saying. I might say that kids in there are about 2 to 5. There's some older ones. But older ones you traditionally don't need to worry about. But age 22 is what we call an outlier. And that's important to know because what if it's a person with special needs? And if it's a daycare, they're going to have to make a lot of accommodations for that person, right? Depending on their level of need. So it's good to make note of that. Very good. But there are 6 kids older than 5. Now we got to ask ourselves, how many kids are younger than 5? What do you think? How many kids are younger than 5? Yeah, there's 10. So mathematically, is the mean a very good way to talk about our data?
It's the word.
It's the word you were talking about, right?
Yeah.
Yeah, outlier. I knew you knew what it was. But sometimes it's just weird remembering that word. But what do you guys think? If we have 10 kids that are smaller than the mean, but 6 that are bigger, do you think we should use the mean to talk about our data set mathematically, even though there's a lot of other circumstances here? Everybody type no. Type no. Yeah, there we go. There we go. Okay, I got you. This part is kind of weird for people. I get it. So we would say no, we really wouldn't use the mean because it doesn't fit. Because it's not really even. Okay, there's not a good division. Now the median is right in the middle. And the median and the mode are kind of the same. So I would say the best fit in this case could be the median or the mode. And our outlier is that 22. Okay, does that make sense, guys? When you're figuring out what the best fit is, and I believe this is not a Math Excel assignment. I'm going to double check that. So you can explain yourself. Explain why you think that way. Because I'm the one grading it, and I'm going to double check that right now. So, I'm a pretty fair grader, I'd like to say. If you justify what you think, I'm going to check though. It might be in Math Excel. But if it's in Math Excel, then you guys know how to kind of.
It's in Pearson.
It is. Okay.
Yeah.
Oh, wait. Oh, no. Guys, this is not a Math Excel assignment.
Oh, no, this is the 5 multiple choice questions.
Yeah, this is okay.
All the other ones are Pearson except
Yeah.
for, of course, target time.
Right. So, guys, you don't have to worry about this one. This one, there's a little description up there. There's a good video. And then there's only 5 questions. You got it. You got this.
I got a 100% in 52 seconds.
Did you really?
Yeah.
That's awesome. Good stuff.
My grandma checked on me and she's like, "What the heck? What did you do?"
Oh, nice. Very good. So yeah, does anybody have any questions about this stuff? Yeah, and what's cool is you get unlimited attempts there. And if it doesn't work for some reason for unlimited, let me know and then I'll fix it. Okay, cool. So guys, let's talk about histograms. I think you do too. I think you guys do. I love talking about data, so I have a tendency to over-explain a little bit. So I apologize if that happens. So, yeah. All right, let's talk about histograms. Histograms are a great way to show results of continuous data like weight, height, how much time it takes to do something, etc. Okay, you guys know how, look at how it's different. A lot of people confuse histograms and bar graphs. Okay, bar graph kind of just measures how far up something goes. Like it separates it into categories. In a histogram, you're going to have a range of numbers and there's no gaps between the bars. It's huge. If you have gaps, bar graph. No gaps, histogram. Okay? So bar graphs is more just like straight up measuring something. Histogram talks about how often stuff is in that category. Okay, so for this one, I would say the US brings in a little under 200, probably billion or something like that. I don't know what it is. But this one says, well, there are about 23, whatever that y-axis is, in the 100 to 150 category. It measures how often something shows up, just like what we were talking about in that bar or that line plot. Yeah, a lot of people confuse histogram and bar graph because it looks like a bar graph, but there's no gaps. So if you have gaps and a category, bar graph. Okay, so Heidi, we're going to create a histogram together. It's going to be awesome. We got this. And my cat actually ran off with my stylus, so I'm going to have to use my mouse today. Yay, thanks, kitty. So, excuse me. Heidi measured the temperature at 2 p.m. at the same point in her garden and recorded her results each day for the month of June. So she's measuring the temperature at 2 every day in her garden. Her results were as follows. So before you can make a histogram, you have to make a frequency table. So you have to kind of tally it up with how many times those different temperatures showed up. And this is not in order, right? Is this in order? What do you guys think? Or not in order? It's important to know that. Not in order, yeah. So we're going to have to put it in some kind of order, okay? So 60 to 64. So we're going to count the number of days that the temperature was 60 to 64 degrees. Okay, so we're going to look at our list and we're going to say, oh, there's 63, so there's 1. So I'm going to put 1 as kind of my tally there. And let's check all the data. So 60 to 64, there's a 65, but we don't care about that one. Oh, there's a 62. So 2 days. 2 days it fell in that category. Okay. So now we're going to go 65 to 69. How many oh no, Henry, you're not playing video games, are you? I can see it. Yeah, that's pretty cool. But Henry, I don't know if you know that we can all see your screen there.
Don't think he knows that we can hear him either.
Yeah, so I'm going to stop the video there just so we don't get distracted. Guys, don't forget, when you're in live session, you have to be paying attention to the live session, okay? So It's a pretty short live session. You will definitely be out of here on time.
Can't
But you
be
gotta
on
focus.
any of those screens there.
Yeah, you gotta be focusing because we're only gonna do this example of histograms, and then I think this is about it. I think we're answering questions about histograms, and then we're done. Okay, you see 3. Okay, 3 in that category. I believe you. Let's check. 1, 2, 3. Yep, I agree with you. Good job, Junior. You got it. Okay, so now we need to count how many are in the 70 to 74 category. What do you guys think? Okay, I have my number. What do you guys think? 70 to 74 category. Oh, I didn't see 3. I saw 4.
I think, yeah.
Did you guys see 4? Here,
Yep.
I'll show you.
That's
1,
1, 2, 3,
2.
71, and that's 4.
Yeah, remember 74 counts because it's still a part of that that category there. So 4. That's okay. And I really love how you guys are like, wait, I see this. I love that. That's how it should be. Good job. Okay, so now 75 to 79. Okay, I have my number. I got 5 too, yeah. Good stuff, guys. Totally agree. Okay, now 80 to 84. You might be asking yourself, is this the pain in the butt part about this? Yes, it is. But, it's all a part of data collection.
It's not that bad.
Yeah, it's not terrible. Yep, I got 5 as well.
And that is my 5. I see 5.
All right, now 85 to 89. What do you guys think? I got 4. Yep, good job. Good. Okay, what about 90 to 94? I think I have 5. Hold on. Let's check. We always double check because wowie, this part can be a pain in the butt. So 1. Wait, I'm going to go through a different color. 1, 2. 5. Yeah. Oh yeah, it can mess with your brain a little bit. Yeah, go slow, take your time, recount, maybe use, guys, if you like a screenwriter to help you with your homework, you all can download one at Epic Pen. If you type in Epic Pen into Google, later, not now please, but later you can download a free screenwriter. Also, there's WebPaint for Google Chrome. That works too. So it helps when you're doing all this data stuff, but I definitely got 5. Good. And now the last one, what do you guys think? Oh, Sarah, this might be the one that you're talking about for the very last one.
I see 5. Oh, no, 6.
This is in the 95 to 99 category.
Oh, oops.
There's only 2 in this one, yeah.
I was looking at the wrong thing.
Yeah, that happens. Totally happens. Okay, so we have our frequency. We have how many times each temperature showed up and in that range. So now we're just going to put it on the graph. And I am going to use the line tool so I don't, and we want to make sure that, usually you'll have it right next to the y-axis here, the number of days access, but sometimes, since there's really nothing from 0 to 60, you could just kind of do it how it's done on the screen. So we'll go up to 2. And when you make your intervals, they should all be the same width. You don't want to have one that's wider than the others, otherwise it might be confusing. This one's going to go up to 3. Okay, what should I bring my next interval? Could someone put my next interval up there for me? From 70 to 75 up there. Notice how it looks a little bit different. But that's okay. Because from 75 it takes over to a new one. So it's okay to list it right like that. Anybody want to do the next interval for me? Please. You can all use the line tool I just did. Otherwise, you can try and just color it in there. It's all good. We don't need to be precise. Perfect. Yep, up to 4. Well, that's okay. That's why we have an eraser. And I doubt it. It's all good. And what's cool about this, I have no idea who just wrote that in there. They did a perfect job, but I don't know who did it. So no one can get ya. All right, now what about the next one from 75 to 80? What would that one be? Technically 75 to 79. Oh, well, you did perfectly, my friend. Good job. All right, what about 75 to, yep, it's going to go up to 5 because there were 5 days where it occurred. Good. So I'll put the text in the box for each one that we did. So we did this one, it was 2. This one was 3. This one was 4. This one was 5. What about the next one? From 80 to 84. And on the graph, it looks like 80 to 85 just because we don't want to have an 84 and then an 85. What do you guys think? Yep, perfect. Very good. Very good. All right, what about the next category? 85 to 89, or 90, according to the graph. Perfect. Yep, it's right at 4. Good. What about 90 to 94? Yep, it is at 5 again. Good. That's perfect. And then the next one, 95 to 99. Perfect. Look at that. And I love that there's overlap. I love that. Very good. Very, very good. Because that tells me that more than one person is doing it. Love that. Very good. So that is a perfect histogram there. We have all of our stuff is right? I love that. All of our bars are relatively the same size. There's no gaps. It's perfect. Does anybody have any questions about how we created that? So we can kind of see what are the more common temperatures in what range. What are some of the more common temperatures? What range of temperatures? Would you guys say about 75 to 85? Is that pretty accurate? But there's also some high 90s there. It's a good variety. Do you think a graph like this, we could very easily, if we didn't have the data, so pretend you don't see the data at the top, but if we just had the histogram, could we really tell like what the average was? Or like the exact highest temperature? The number of days, yeah, we could tell the frequent number of days. We totally could. You're right, but we couldn't tell what the exact temperature number would be if we just had the graph. Because in a histogram, you don't get exact values, you just get ranges. So we couldn't tell what the highest or the lowest temperature is, right? Because in the 60 to 65 interval, 60 is the smallest number in the interval, but we didn't have any 60-degree temperatures, did we? We did not. So histogram is for ranges. Yeah, no, good stuff. Good stuff. Okay, so this is the histogram, okay, that you guys made except colored in. How many days was the temperature under, we'll say 85? How many days was the temperature under 85 degrees? I can see how it cut off there, but I'm just inventing stuff. Ah, sorry, that was bad. Under, we'll say 85 degrees. What do you guys think? How many days was it under 85? So let's identify where 85 is on the graph. It's right here. There's 85. So now how many days is it less than that? 19? Yeah, let's check. There are 5 days in the first category, 5 days in the second one, 4 days here, 3 days here, 2 days here. Does that add up to 19? I think it does. Yeah. You guys see that? We just count how many days are in each category under that 85. Good. Very good. How many days are greater than or equal to 85 degrees? So greater than that.
Yeah.
Yeah, I'm going to agree with Isabel there and
I
Aiden. Very
agree.
good. Yeah, you're right.
That's 4 plus 5 plus 2 equals 11.
Yep, very good. That's all you're doing here. You're just adding the different columns. Good stuff. Yeah, so those are questions you'll be asked about it. Does everybody see how we got that? You're going to
Yeah.
look at the temperature and then just add the numbers in the categories. Okay. And if you don't see that, that's okay. Ask me questions. I'm here to help. So that's what I have for you today. That is it, my friend.
Graph.
So we have a bar graph there, right? I don't know. I have too much fun. Okay.